In our last video, we talked about collections and lists, and two of the most common things we would like to do with lists is to search them and sort them. In previous videos, we've covered two different searching algorithms called linear and binary, and in our last video we covered the selection sort. The selection sort algorithm is the easiest to grasp but the most inefficient. Today we're going to cover the insertion sort. Now, the insertion sort has two different values that it holds. The start index is one thing we hold, that's a carryover from the selection sort. But instead of holding the min index, we're going to hold the value of that index. And we're going to hold the value, we're going to scoot the values that are greater than, and then we're going to insert it back in. So what does that really mean? Well, let's take this for example. We're going to keep track of the iterations as we go through the sort. So when we start with index, rather than starting with index 0, we're going to start with index 1. So we're going to hold the value, start the index with index 1. The hold value, we take and hold it in a temporary value somewhere. We then look to the left of that value and continue to shift down values that are greater than that number. So we see that 25 is less than 43, so we're going to scoot index 0 down. Since there's nothing to the left of 0, we're done with our scoot. We then insert our value back into 0. So in our first iteration, it looks like 25, 43, 4, 19, 7, 20. Now, take into account the sort that we're doing is sorting it from lowest to highest. We'd have a different algorithm. We'd swap it if it was less than the value that we held rather than greater than the value that we held. So we've locked this down. Now we're going to start with index 2. We hold off that value and we compare to the left of it. Is 43 greater than 4? It is, so we scoot it down 1. Is 25 greater than 4? It is, so we scoot it down 1. Since there's nothing to the left of that, we then insert 4 back to the beginning. You can start to see a pattern here. So our next iteration is 4, 25, 43, 19, 7, 20. So start with index 3, hold that value. Now we start to compare. 19 and 43. 43 is higher, so we scoot it down. 19 and 25. 25 is higher, so we scoot it down. 19 and 4. 4 is less than 19, so it's already in the right order. We insert it back into that position. So our next iteration is 4, 19, 25, 43, 7, 20. Okay, going to the next index, index 4, we hold off 7. Now we start looking to the left of it and comparing. 7 is less than 43, so 43 gets scooted. 7 is less than 25, so 25 gets scooted. 7 is less than 19, so 19 gets scooted. And 7 is greater than 4, so we stop right there and insert the value. Our next iteration passes 4, 7, 19, 25, 43, and 20. Last but not least, we start with index 5. Hold that value. 20 and 43. 43 is higher, so we scoot that down. 20 is less than 25, so we scoot that down. 20 and 19. 19 is less than 20, so we found where this belongs. Insert the value, and our array is sorted at 4, 7, 19, 20, 25, and 43. even though it took the same number of iterations, there was less operations per iteration. So when you have a larger array or a larger list, the performance impact is more significant. There are a couple more sort techniques that we're going to cover later on when we cover recursion, but these are the two basic sorts we need to cover at this point.